Non-recursive descent parser. How it works? So initially we cross-check the input string with this special symbol, this symbol. If the symbol we reach to the symbol, it means string is successful, dollar. Then we are doing this thing with non-recursive descent parser, that is also called LL1 parser. And we do this thing with the help of LL1 parsing table. And this LL1 parser is related with the stack, because we are cross-checking a string one by one, so we are putting all these variables into the stack until we reach to the final completion. So what is LL1? We can say what is LL1 parsing algo, through which we are going to do such things. So there are some steps which we need to follow. Suppose if x is the top of the stack, and a is the look ahead symbol, then first what we will do, if x is equals to a, that means look at symbol, and this equal to dollar, then we can simply say the successful completion. It means we reach to the destination, we reach to the end of the string, it means successful completion. The second one, if x equal to a and that not equal to dollar, then increment input, means we have not reached up till end of the string, so input increment and pop the top of the stack, whatever variable is available on the top, pop that and go further. Then third, if x is variable, then see the table, that is table, this is x variable, this is look ahead symbol. And if m x comma a equal to, in which we have x equal to u v w, because x is a variable, then replace x by u v w in reverse order. Why in reverse order? Because if there is a left recursion is available, so we want to remove the left recursion from the algorithm, from the string, so we will go by in reverse order. The next one, if m x a means the table is equal to blank, you don't have anything in the table, that means there is some error. So this way we are working with the non-recursive descent parser. Suppose we are going to take one example, e tends to e plus t oblique t, t tends to, we have this grammar. Suppose we have this grammar, so because this contains left recursion, so first we are going to remove the left recursion, because we have e tends to e plus t, t tends to t star f. There is left recursion, so we need to remove it. We know how to do it as we have learned earlier. So e tends to t e dash. We will take another variable where e dash will be either epsilon or either plus t e dash, and in the similar way we will do it for this production. This will be t tends to f t dash, new variable, then this new variable t dash tends to epsilon or star f t dash, and this will remain same, f tends to, because there is no left recursion, id oblique e. So this will be the grammar. So I'll just show you how we can make the table regarding this. How many terminals we have: id, starting bracket, closing bracket 3, plus and star 4 5, and dollar is a special symbol, we can say, and which represent this is the end of the string, so this will be a symbol. So how many terminal we have? We have id, we have a starting bracket, we have closing bracket, we have plus, we have multiplication star, or we have dollar. So these are the variable of the table. And how many variable we have? We have e, we have e dash, we have t dash, and we have f. So these are the variable of the table, and these are the terminal of the table. Like that it will go, and we will get such kind of table, and entries will be given to us initially. Later we will learn how we can make a table. So this time I'm showing you how the table look. So e tends to t e dash, e tends to t e dash, e tends to epsilon, e dash tends to plus t e dash, or here t tends to f t dash, t tends to f t dash, and t tends to epsilon, f tends to id, f tends to e with the bracket, and here t dash tends to epsilon, and here t dash tends to star ft dash, and here e tends to epsilon, and here t dash tends to epsilon. So like that we will get the table. So this is a LL1 parser table, but here suppose instead of this we have two entries like this, t dash equal to star ft dash is also there in the similar row, in the similar. So we can similarly see there are two entries. So if we get this kind of entries in a table, then this is not LL1 parser, it will be then LL2 parser. If there are two entries in a particular box, then we can simply say this is LL2 parser. But if we are having only one entry for one column, then this is called LL1 parser. I am just showing you, I am just giving the reflection how the LL2 parser will look. If there are two entries, then it will call LL2 parser. But in this table we have only one entry, so this will call LL1 parser.